Hello guys, today our topic is the most important topic, tricks to find geometrical isomerism for BSc and MSc students. So how to find out the geometrical isomerism to a molecule. So this is the most important topic. So simple tricks we have to listen carefully. So first one, case 1. So what is case 1? For tetrahedral complexes. So case 1 for tetrahedral complex. So this is the diagram for tetrahedral complexes. This is A and this is B and at the same time D. So this is the C. So in this tetrahedral complexes, the angle is 109 degrees 28 minutes. 109 degrees 28 minutes for all the three angles. So now we have to flip this two, that means A and B. Now we have to flip this two. What is the changes? The same angle between these two and these two. So listen carefully. This is the tetrahedral complexes. When you flip this angle like this, there is no change in angle, right? If you flip this 109 degrees 28 minutes, if you flip this 109 degrees 20 minutes, if you flip this same. So in this complexes there is no change in the angle between these two. There is no change in the angle. So this is, so that's why for tetrahedral complexes no geometrical isomerism. For case 2, the second point is case 2 for square planar. For square planar, so two types is, that is monodentate and bidentate. We have to explain this. For case 2 for monodentate, so that means first you have to take this one complex. That means you have to take like Ma4. Here you have to observe carefully, right? This is a Ma4. M means central atom. How many ligands is there? A. This is the structure. So in this structure you have to flip like this. That means you have to flip these two. You have to flip like this. There is, so when you flip these two, there is no change. Same structure. That means this is A and this is A. When you flip, this is A, this is A. There is no change. When you so there is no change. So same structure. So no geometrical isomerism. And second example, Ma3b. This is the central metal atom that you have to write like this, AB. So A and B. So this is the structure. Now you have to flip like this. What happens when you flip like this? This is this B is changing to A. This changing to A. So now you have to write this B that side, A and A and A. So only flip like this, only two interchanges, remaining all same. So now this you observe A is perpendicular to, now you have to observe A is perpendicular to B and A is perpendicular to A. Same, B also same structure, no change. So that means no geometrical isomerism. That means you have to observe carefully. A is perpendicular to B. Again A is perpendicular to A. B. In this structure also, when you flip like this also, A is perpendicular to B and A is perpendicular to A. So same structure. That means there is no change in these structures. So that's why here also no GI. And Ma to B2. So this is the structure. We have to write like this. So now we have to change the structure become That means now in this structure you have to carefully observe. If you take the complexes, now you have to how many number of possible pairs, that means positions, that means how many number of sets possible you have to observe like that. That means this is how many, this a you have to write like this, and this b you have to write like this, and another form is ab, again ab. So two sets. When you observe these two sets, that means a is perpendicular to a, b is perpendicular to b. Now this is a is perpendicular to b, now this a is perpendicular to b. So here two geometrical isomerism is there. The number of sets you have, first of all you have to, this is the trick. When you given the component number of sets, how many number of sets is possible, you have to calculate that. The number of sets is the geometrical isomerism. The number of sets is possible, we have to write the complexes like this, and observe a is perpendicular to b, a is perpendicular. That means you have to, this is the cis, that is a is opposite to a and b is opposite to b. Second one, b is same side and a is same side, so this is the trans. So what is I am saying here, first of all you have to observe how many sets possible in the given compounds. So how many possible sets, that possible sets are called as the geometrical isomerism. So m a b c d, for example you have to take like this. So here how many possibles is there, a b c d, this is one set, and again AC AD, that means AC AD, and again BC AD. So here three sets is possible. So how many geometry isomerism is? Three geometrical isomerism is possible. So this is the most important topic for monodentite ligand. For how to calculate it, first of all what you should, this first you have to write number of sets possible, and that number of sets are geometrical isomerism. So when you given compound, that how many number of sets is possible, you have to calculate this. That coming to this one, no geometrical isomerism, so you have to write like this, a and a for now, how to write like this, a and a, there is no change. That means the same sets you have to calculate, so there is no geometry. Coming to this ma3b, now you have to write like this, a ab. Whenever you write a ab, that means there is no structural changes or else any. So this is the most important topic. So I have given the notes in same for monodentate ligand. So listen carefully, this is the monodentate ligand, and description lo link ichchanu. Bident ligand kuda I really explain that. So this is the exam explanation, and this is the exam this is the notes for geometrical isomerism for BSc and MSc semester exams. So this is the notes, that is the explanation, and this is the monodentate ligand. I after that I explained bidentate ligand for square planar, that notes also given, so you can check it. And this is the easy topic, and that is the tricks you have to find like this. And this is the most important topic for BSc and MSc students. Don't miss to watch and subscribe చేసుకోండి, మీకు వీడియోస్ కనిపిస్తూ ఉంటాయి. థ్యాంక్ యూ గైస్.